Hello. Okay, now we want to continue with shifted arithmetic gradients. Okay, shifted arithmetic gradients begins at a time other than between periods 1 and 2. And present worth, we put it as PG, is located 2 periods before gradient starts. Okay, 2 periods. And it must use multiple factors to find P total in actual year 0. To find A series, find P total at actual time 0 and apply A over P IN. Okay, right. So for example of shifted arithmetic gradient, John Deere expects the cost of a tractor part to increase by 5 ringgit per year beginning 4 years from now. If the cost in years 1 to 2 is 60 ringgit, analyze the present worth in year 0 of the cost through year 10 at an interest rate of 12% per year. So what we're looking is for P total at P0, P naught over here. What it says here, the cash flow diagram, he pays 60 ringgit from year 1 to year 3, and then the cost increases from year 3 to year 10 by 5 ringgit every year. Okay, this is the gradient. Okay, solution. First, find P2 for G, which is RM 5 ringgit, and base amount RM 60 ringgit in actual year 2. Okay, so find the base amount. So you want to find A 60 ringgit until year 10. A here. Until 10. Okay. So how do we solve for that? P2, P at 2, okay, it always start 2 years ahead, okay, 2 period, okay, ahead, okay, P2, right, equals to 60, P of A, 12%, N of 8, plus 5, P of G, the gradient, 5 ringgit, 12% at 8, N equals to 8. Equals to this amount of money. Then move P2 back to year 0. So you move whatever you get at P2 here, get a P2 here, P2 here, over here, and then to back to year 0. So for that you can find P total. So P naught or P total equals to P2 times P of F at 12% for 2 periods, period 1 to 2. So it is RM 295.29. Next, to find PA for the RM 60 amounts for years 1 and 2 is equivalent to PA 60 ringgit times PA 12%, 2 periods. Okay, here. So this is the PA, which is 100 ringgit, 101.41 ringgit. Finally, we add up P total, P naught plus PA equivalent to these figures. Okay, this is how we solve for arithmetic gradient. Example of shifted arithmetic gradient further. Okay, the question says, analyze the present worth year 0, okay, year 0, of the cash flow diagram below at an interest rate of 10% per year. So you want to find P naught, okay, P naught. So you can have two approaches in order to answer this. Okay, the second one. First, you take the first two as the series, and then from n equals to 3, you take it as the next series. Or you can also take the first 3 of the values here as the first series and the next as the second series. Both ways work. Okay. Analyze the present worth in year 0. The cash flow diagram is shown below. Okay. So interest rate is 10%. So now you have A series up to year 4 and your gradient series from year 5 to year 4. So you can either solve this way and this way, or you can solve this way and this way. Okay, example, shifted arithmetic gradient. FKP automation in Nevada has tracked the average inspection cost on robotics manufacturing line for 10 years. Okay, N equals to 10. The cost average were steady 1,000 ringgit completed unit for the first 5 years. And A equals to 1,000 for NA equals to 5. But have increased consistently by 200 ringgit per unit for each of the last 5 years. So you have 10 years. Okay. 1, 2, 3, 4, 5. 1,000. Okay. It's not erasing. Okay, and you have for the next 5 years. Okay, this is 5, 6, 7, 8, 9, 10. A gradient that increases by 200 ringgit, the G value. So you can break it down and get the answers quickly. So now we move on to shifted geometric gradients. Okay, shifted gradient begins at time other than between periods 1 and 2. And equation yields PG for all cash flows. Okay, the base amount A1 is included. And you must use equation. So you can't use the compound table because it is geometric gradient and we can only use the equation to solve this kind of problem. For negative gradient, change signs on both of G values. So it becomes negative value. All right. For example of shifted geometric gradient, okay, Wilton Steel signed a 5-year contract to purchase water treatment chemicals from a local distributor for RM 7,000 ringgit per year. When the contract ends, the cost of the chemical is expected to increase by 12% per year for the next 8 years. If an initial investment in the storage tanks is 35,000, determine the equivalent present worth in year 0 of all the cash flow at R equals to 15,000 per year. Okay, the geometric gradient, it increases at percentages. So this is where the G starts from here and here. So you make 2 series, separate them, find the A here, find the G here, find the value of A series here, get the P naught from P naught equals to PA plus P total. Okay, just follow the method that we've shown you before in the previous examples. Okay, so here are the solution. You can analyze the solution here. Okay, and you got the final answer of 83,000 ringgit 232. So negative shifted gradients are for negative arithmetic gradients, where the change sign on G term from positive to negative. General equation for determining P is P equals to present worth of base amount minus PG. For negative geometric gradients, change signs on both G values. Change from positive to negative. Okay, this is the equation when you have a negative gradients. All of the procedures are the same for positive gradients. So when you answer your question later, you have to determine whether for a shifted gradient, especially for geometric gradients, is it negative or positive? So the polarity changes when the gradient changes sign. Okay. Example of negative shifted arithmetic gradient. For cash flow shown, find the future worth in year 7 at I equals 10% per year. So this is a negative shifted, right? It decreases. So find PG. Solution, find G first occurs between actual years 2 and 3. These are grading years 1 and 2. PG is located in gradient year 0, actual year 1, and base amount RM 700 ringgit is in gradient years 1 to 6. So solving for this, PG equals to 700, okay, here, times P of A 10% as n equals to 6 minus PG 50 times PG 10% n equals to 6, and you get the values here. So for the future worth would be PG FP 10% 6 times 6 n equals to 6 equals to RM 4,554 ringgit. Okay, summary of the important points. P for shifted uniform series is one period ahead of the first A, and n is equal to number of A values. F for shifted uniform series is on the same period of the last A, and n is equal to numbers of A values. For gradients, first change equal to G, or G occurs between gradient years 1 and 2. For negative arithmetic gradients, change sign on G from positive to negative. For negative geometric gradients, change sign from G on G from positive to negatives. Right, that concludes for today's chapter 2.